7, we'll be looking at inputs, outputs, and relating them to independent and dependent variables. And that will be our intro into something called domain and range. So it says your teacher will display a list of values, categorize them into possible inputs and outputs. Each value will be used only once. So if we take a look at the first situation, it says the area of a square in square centimeters is a function of its side length, s, in centimeters. The equation a of s equals s squared defines this function. So I'm just going to go through and underline these things that I would have displayed on the board. So we have area in square centimeters is a function of its side length in centimeters. The second one, a tennis camp charges $40 per student for a full day of camp. The camp runs only if at least 5 students sign up. It limits the enrollment to 16 campers a day. The amount of revenue in dollars that the tennis camp collects is a function. So the revenue is a function of the number of students. And then the last one, the relationship between temperature in Celsius and in Kelvin, all right, so temperature, can be represented by this function k. The equation k of c equals c plus 273.15, and it defines this function, where c is the temperature in Celsius and k of c is the temperature in Kelvin. So possible inputs, let's look at each equation. And if we take a look at the first one, what is the input of this equation? It would be side length. Remember, input is in the parentheses. And then the output would be the area. In the tennis camp, it says the amount of revenue is a function of the number of students. So what's the input would be the number of students. And it has to be between 5 and 16, so you could also write something like this. The number of students has to be at least 5 and up to 16. And it says that the amount of revenue is a function of that, so it would be revenue. And then the last one, it says right here that C is the temperature in Celsius, so that's what we're putting in. And then it's a function of K, which is the temperature in Kelvin. So this will be degrees Celsius, degrees Kelvin would be the output. We have studied independent and dependent variables. Are the inputs the independent or the dependent variables? The independent variables are the inputs. The dependent variable are the outputs. Let's look at the graphs. Here's a graph that represents function a defined as a of s equals s squared, where the side length s is the side length of a square in centimeters. Name 3 possible input-output pairs. Okay, so I'm going to make a table. Input, output. And when the input is, let's find ones that are like not fractional answers. Okay, so when the input, I guess it is a decimal, okay. 4.5, the output is 20. When the input is, that's another one. Ooh, this one's good. When the input is 5, the output is 25. This one's pretty good too as well. When the input is 6, the output, no, 5.5, the output is 30. So we could write them as a table. We could also write them as like ordered pairs. The input comes first, the output comes second. It says earlier we described the set of all possible input values of A as any number greater than or equal to 0. How would you describe the set of all possible output values? All right, so the input starts at 0 and it's any number bigger. The output, again, if we look at the output, starts at 0 and it's any number bigger. So the output, again, is any number greater than or equal to 0. 2, function r is defined by r of n equals 40 times n, where n is the number of campers. Is 20 a possible output of this situation? All right, so if the input, so here's the function, 40 times n. So this is saying, okay, so we have input, output. This is saying, is 40 times a number equal to 20. Let's try that. Let's solve it. If we divide by 40, which is 1/2. So can the number of campers be half? And we know that number of campers, if we're talking about people, it can't be a fraction of a person. So no, 20 is not a possible output value. How about 100? Okay, so let's check the 100. So if I erase this right here, we want to know, we have this equation 40 times n. Can that equal 100? Let's divide by 40. And again, this will be a fractional answer. 40 does not go into 100 evenly. So we could say that no, you can't have, the number of campers would be 2.5. And the number of campers cannot be a decimal. So you say no. Here are two graphs that relate number of students and camp revenue in dollars. Which graph could represent function R? Explain which one could not represent the function. So right here, if you notice, we have like fractional number of students. So like you have, like if this is 1, you have like half a student there, and you know that wouldn't work. So this graph would have to be the accurate one for this situation, just because you can't have like part of a student. Describe all possible output values of R. So it's going to be amount in dollars. So we could say R is greater than or equal to 0. Consider the function 6 divided by x minus 2. To find the sets of input and output values of the function, Claire created a table and evaluated f at some values of x. Along the way, she ran into trouble. Find f of x for each value Claire listed. Describe what her trouble might be. Okay, so let's try plugging in. I should have given you more room here, but I didn't. So f of negative 10 equals, and then here's the f function, 6 over negative 10 minus 2, 6 over negative 12, which is negative 1/2. Okay, so we can get it. If the input is negative 10, we can get an output. Let's try the next one, which is 0. 0 minus 2. Okay, that would work. We'd get negative 3. Let's try another value. So what if we plugged in 1/2? 1/2 minus 2 is negative 1.5. Can we divide that out? Yes, we can. Okay, that would give us negative 4. Okay, let's try this one. Let's plug in a 2. Can we divide 6 by 0? That's undefined. So this one right here would be undefined. Can we do 8? Eight minus 2 is 6. Yeah, we can do that. This one. So it says using graphing technology, graph our function. Okay, so let's pull up a graphing calculator. This will take a second for me. What will a graph look like? Because we have this undefined value. So we'll take a look at what does it look like when we have an undefined value on a graph. So I'll pause and let this open up here. Okay, so to graph, there's a few places we can do it. We can open a graph page, or we can use the Scratchpad graph. I will open a graph page. So if you go to the Home button, New Document, and at home you can do this. You can graph this really easily in Desmos too. So add a graph. I'll show you both maybe. All right, so our function was 6 divided by, and then let's put the new denominator in parentheses, x minus 2. So we graph that. Here's what it looks like. And we knew that at the value, when x is 2, it's undefined. So here's where x is 2, all along this line right here. And you can see that there's no graph there where it's undefined. Any other spot in the graph has a function associated with it. But again, at x equals 2, there's nothing there because it's undefined. And then if you want to use Desmos, you can do the same thing. So at home, if you have the free graphing app, you should be able to graph and try to find this as well. Okay, so we had f of x, which is the same as y equals. And then it was 6 over x minus 2. And we can, again, see that at x equals 2 here, there's no graph because it's undefined when we try to plug it in. Okay. Oh, how would you describe the inputs of f? Okay, so the inputs are everything except -2. So our x values, so it can be any number except 2. Another way to write that is like any number. We call this any real numbers. It's a line, 2 lines with an R, except x cannot equal to -2. So I would say x would not equal -2. All right, summary. We have another name for inputs and outputs, and this will be really what we get into tomorrow. Those inputs, so inputs are independent variables, inputs. Those are called the domain. So domain is input. The output is the range. So the way I remember it is domain is x, range is y. It's alphabetical, right? X comes before y, D comes before R. So today we're going to take a look at domain and range and how to classify them. So your assignment will be page 28, and it will just practice these ideas of domain and range, input and output, and then there's a review practice problem as well.